This video is about sketching polynomials, and let's start off by just writing out a polynomial as an example. Y equals negative x cubed minus 2x squared plus 5x plus 6. Now, there are three features that we're going to analyze. One of the features is referred to as end behavior, and we've discussed that in a previous video. Another of the three features is y-intercept, and the final set of features, and there might be more than one x-intercept, the last feature, x-intercepts. Now, end behavior, previously we've stated that the highest order term, in this case negative x cubed, will control the behavior of the function at the extreme right-hand end of the x-axis and at the extreme left-hand end. At the extreme right-hand end, we have a positive x value, so it would be something like negative times some positive number raised to the third. Carrying out the consequences makes you realize that this is going to be a negative number. So the right-hand end behavior is downward. Now, negative x cubed at the extreme left-hand end of the x-axis would be a negative number, -1 in this case, times some relatively large negative number raised to the third. This overall result is a positive number, meaning that when you move far to the left on the x-axis, the overall sketch will go upward. So, right-hand end behavior is downward, and left-hand end behavior is upward. Now, the y-intercept is easy to find. You just, in the equation, set x equal to 0. Now, any term which involves x will be 0, so the y-intercept is 6, and it occurs at the coordinates 0, 6. Probably the easiest way to proceed from here to find x-intercepts is to have the calculator help out, and so let's do that. Type in the actual function, negative x raised to the third minus 2x raised to the second plus 5x plus 6. Now, to set up a proper window, perhaps the easiest way is to proceed by pressing the middle button, zoom, and choose option 6, Z standard. What this does, it sets up a window that runs from x -10, x +10, and y -10 to y +10. And you can look at this, and it looks an awful lot, based on this scaling on the x-axis, that -3 might be an x-intercept. Now let's check that out by using an option in the second calc menu, and that's the value option. Now, choosing value, we can type in 4x -3, press enter, and you can see right here, yeah, y is equal to 0. So -3 is one of the x-intercepts. So let's put that down. -3 is one of the x-intercepts. That means that the point 0 with coordinates 0, -3 is on the sketch. Now, let's find some of the others. It looks like it crosses at -1. Second calc, let's just verify that. Option, value, put in -1, press enter, and the y value does equal 0. So negative 1 is also an x-intercept. Whoops, I notice I've got this running backwards. I'm going to make the change. The coordinates for the x-intercepts are negative 3, 0, and negative 1, 0. And the third one looks like occurs at positive 2, and that's true. The third intercept is 2, 0. So let's put some of this information down. 0, 6 is the y-intercept. Negative 3, 0 is one of the x-intercepts. Negative 1, 0, another x-intercept. And finally, 2, 0. Putting that together with the end behavior, which says that on the left the function goes up and on the right the function goes down, means that the overall sketch looks probably something like this. And there we have the polynomial. The final aspect of finishing this problem is to write the polynomial in what's called factored form. Now, at the very beginning of the problem, the coefficient of the highest order term, in this case negative 1, that will be the beginning to writing the factored form. So put down negative 1. Then each of the x-intercepts will contribute a factor to the polynomial. And so here is how that happens. The first x-intercept is negative 3. Each x-intercept or root will correspond to a factor. In this case, negative 3 corresponds to x plus 3. Negative 1 corresponds to x plus 1 as a factor. And finally, 2 corresponds to x minus 2 as a factor. So in the red box at the end of the problem, that is the factored form of the polynomial. Now, just a little bit more about this relationship between polynomials and factors and roots and x-intercepts. This is a third degree polynomial, and there's a theorem that says a third degree polynomial will have 3 roots. Now, in this case, each of the 3 roots, we've already looked at them, is obviously a real number, and these are also integers. It will not always be the case that you will find integer roots, but this time we did. We have 3 of them, so we can be sure that there aren't any others because this was a third degree polynomial.